Hey everyone, and welcome. So, today we're going to talk about something really fundamental, the blueprints for building software. From the simplest app on your phone to these huge complex systems, every single one follows some kind of plan. But what are those plans? What do they look like? Well, that's exactly what we're here to figure out.
Seriously, think about it. How does great software actually get built? It seems like a simple question, right? I mean, we're surrounded by it all day, every day. But how does it get from just an idea into a real working thing on your screen? It's not magic, that's for sure. And spoiler alert, it's way more than just slamming out a bunch of code.
Well, it turns out it all starts with a kind of universal blueprint. And here's the cool part. No matter how different two software projects might seem, deep down, they're built on the same set of fundamental stages. This blueprint is the foundation for everything. And if you can get your head around that, you're already halfway to understanding how it all works.
Okay, so before we start comparing different models and ways of working, we've got to understand the core steps that all of them share. Think of it like this. You've got your fundamental ingredients. Different recipes, or in our case, models, might mix them up in different ways, but the basic ingredients, they're always the same.
And here they are, the 5 universal stages. First up, you've got requirements. This is all about figuring out what the software is supposed to do. Simple, right? Then you've got design, which is the how. How are we going to build this thing? After that, you get to the part everyone thinks of, code and debug, the actual building and fixing of stuff. Next is system testing, which is super important. It's making sure all the different pieces actually work together without breaking. And last but not least, release and maintenance. This is where you get the software out to the people who use it, and then, you keep it running smoothly. So keep these 5 stages in your head, because everything else we're going to talk about is just a different way of shuffling them around.
All right, let's start with the classic. This is kind of the original attempt to bring some order to the chaos of making software. It's called the plan-driven waterfall model. And really, it's all about taking those universal stages we just talked about and organizing them in what seems like the most logical way.
So, let me ask you, if you had those 5 stages laid out in front of you, what's the most straightforward way you could possibly organize them? Yeah, you'd probably just line them up one after the other, right? And that simple, linear thinking, that is the absolute core of the waterfall model.
Think of the waterfall model as a factory assembly line for software. It's super sequential. You start with requirements, and you don't even think about design until every single requirement is documented, approved, and signed off, locked in. Then, you finish the entire design before anyone writes a single line of code. Each phase has to be 100% complete before you can move to the next. It literally waterfalls down. It's a very rigid, plan-driven approach where the whole game is about getting everything perfect right from the start. Now, on paper, this assembly line idea sounds pretty good, right? It's predictable, it's manageable, you always know where you are. But here's the thing. Software development almost never happens in a nice, clean, predictable world. Reality, it has a habit of messing with even the best laid plans.
And this is the million-dollar question. This is what reveals the biggest weakness of the waterfall model. What happens if you're halfway through coding and you realize, uh-oh, there's a huge flaw in the design? Or even worse, what if you spend a year building this thing, you deliver it, and the customer says, yeah, this isn't what we need anymore? What then?
This whole situation leads us to a fascinating idea called a wicked problem. And it turns out that most non-trivial software projects are wicked problems. Here's what that means. It's a problem where you can't actually know all the requirements until you've already started building the solution. Kind of crazy, right? The very act of building it is what helps you finally understand what you're supposed to be building. And you can see how that makes a super detailed upfront plan, well, almost impossible.
So, okay, if you can't count on having a perfect plan from day one, what's the alternative? Well, the answer that evolved over time is a totally different way of thinking, the Agile iterative approach. You can think of it as the direct response to dealing with these wicked problems. So instead of trying to do each of those 5 stages just once and get it perfect, the whole idea here is to do all of the stages, but in really small, really fast cycles. We're talking analyze a little, design a little, code a little, test a little, maybe every single day or every week. You build the thing piece by tiny piece, and the key is you're constantly learning and adapting as you go. Okay, and this chart just lays it all out, side by side. On one hand, you have the plan-driven waterfall model. The whole philosophy is follow the plan. The process is totally linear, one step after another. And how do you know if you succeeded? Well, did you stick to the plan? It's all backed up by tons and tons of documentation. Then you've got Agile. The philosophy here is completely different. Adapt to change. The process is all about these short, repeatable cycles. And success? It's not about the plan, it's about delivering working software. Documentation is kept to a minimum. It really just boils down to this: predictability versus adaptability.
All right, so we've got these two totally opposite ways of thinking. It's easy to think, okay, one must be good and one must be bad, right? But it's not that simple. The truth is, neither one is just flat out better than the other. The right choice, it completely depends on the kind of project you're actually trying to build.
This is the big question every team has to ask themselves when they're starting something new. You've got to step back and look at the whole picture. What's the problem we're solving? Who's the customer? What's our team like? All of that context is what's going to tell you which blueprint gives you the best shot at success.
And this table is pretty much your cheat sheet for making that choice. Let's break it down. First, the project type. If your requirements are super stable and clear, think like a government contract. Waterfall is a great fit. But if things are fuzzy or you know they're going to change, Agile is your friend. Now, what about the team? Waterfall's rigid structure can actually be really helpful for less experienced teams that need that guidance. Agile, on the other hand, really needs a tight, experienced team that can manage themselves. And finally, and this one's huge, customer involvement. If your customer is just going to give you the requirements and disappear, Waterfall can work. But for Agile to really succeed, you need that customer in the loop constantly, giving feedback.
But you know, when you really step back and look at it, even though these two models feel like complete opposites, modern software development has learned one massive lesson from both of them. And it's this: iteration is key. Building things in chunks is the most effective way to tackle complexity. Whether it's a big, planned-out chunk in a waterfall-like process or a tiny, rapid one in Agile, the idea of building, testing, and learning piece by piece, that is the secret sauce.
So what's your project's blueprint? Seriously, the next time you're working on, well, anything, not just software, ask yourself these questions. Is this problem really clear and straightforward, or is it one of those wicked problems where we'll discover things as we go? Do we need a rock-solid plan from the start, or do we need the flexibility to adapt? Because picking the right blueprint, man, that can make all the difference in the world.
Hey, if you got something out of this little explainer, do us a favor and hit that like button. Even better, share it with a colleague who might find it useful. And of course, subscribe so you don't miss out on our next deep dive. Thanks so much for watching.